Hello बच्चों, hope you all are doing well. So today we are going to read chapter number 5 of class 6th, that is measurement of length and motion. Deepa, a curious 11-year-old girl, lives in a town of the state of Haryana. The new school year has started. Deepa needs a new school uniform since she has grown taller. Her mother takes her to a cloth shop. She asks for a 2-meter cloth piece. The shopkeeper measures the cloth using a metal measuring rod. Then the tailor takes her measurements using a flexible measuring tape. Her mother instructs the tailor to increase the length of her uniform by 4 angla, 4 fingers width. Are the tape and rod similar to the scale that the elder sister has in her geometry box? What did mother mean by char angla? Deepa shares her experience with her school friends Anish, Hardeep, Padma, Tasneem, and this leads to a discussion amongst them. 5.1 How do we measure? Hardeep says, I have seen my grandmother measuring cloth by the length of her arm. Have you ever seen how a farmer measures length to divide his field into beds? He walks and counts the number of strides, says Padma. Oh, not just the length of the stride. Sometimes they also use the length of their feet to measure, adds Anish. Deepa says excitedly, measuring length using body parts must be so much fun. Let us also measure something using a body part. What should we measure? Okay, let us measure the length of the table in our classroom, says Tasneem. Padma adds, and which body part should we use to measure it? Deepa says, let us use our hand span. I will show you how to use it. I have seen my mother using it. She called it ballast. Hardeep adds, okay, let us also note down our measurements. Table 5.1 Measuring the length of the table. Name of the student, number of hand spans. Anish, slightly more than 13. Padma, 13. Tasneem, slightly less than 13. Deepa, between 13 and 14. Hardeep, 14. Padma says, oh, the number of hand span is different for all of us. So what we can say about the length of the table? But why should the number be different? Hardeep asked thoughtfully. Tasneem says, I can guess. Our hand span are of different sizes. Anis gives an idea. Let us check this. So all five of them put their hand span along each other and arrive at the conclusion that the lengths of their hand spans are different. Deepa says thoughtfully, no wonder people use scales and measuring tapes. Deepa and her friends compare the length of the table with the length of their hand spans. The length of the table is expressed in terms of their hand spans. Here, the hand span used for measurement is an example of a unit, and the length is expressed in two parts, a number and a unit. For example, if the length of the table is found to be 13 handspans, then 13 is the number and handspan is the unit selected for the measurement. However, handspans and other similar units such as length of hand, foot, fist, or fingers differ from person to person. Thus, there is a need for such a unit for which measurements of the same length made by different people do not differ. More to know. India has a rich history of measurement system dating back to ancient times. Angla, finger width, multiples of Angla, Dhanusha, and Yojana are some of the units mentioned in the ancient Indian literature and used in measuring artifacts, architecture, and town planning. The Angla is still used by traditional craftspeople like carpenter and tailors. Several objects with ruled markings which could be scale have been excavated from sites of the Harappan civilization. Standard units. Several systems of unit evolved with time in different parts of the world. However, When people started traveling from one place to another, it created a lot of confusion. This led to the different countries coming together and adopting a set of standard units of measurement. The system of units now used is known as the International System of Units or SI units. The SI unit of length is meter. Its symbol is m. A meter scale is shown in figure 5.2. 1 meter m is divided into 100 equal divisions. Each division is called a centimeter, cm. You may be familiar with the smaller part of the meter scale, typically 15 centimeter long, shown in figure 5.3. Look carefully at the 15 centimeter scale. It has markings in centimeter from 0 to 15. The length of any section between two consecutive big marks, such as between 1 and 2 or between 5 and 6, is 1 centimeter. Observe that these sections of 1 centimeter length are further divided into 10 equal parts. The length of one of these smaller part is called a millimeter mm. 1 mm is the smallest value of the length that you can measure using this scale. 1 mm is equal to 1/10 of a centimeter. 1 mm is equals to zero point 0.1 centimeter. For measuring larger length, we use a larger unit called a kilometer, km, which is equal to 1000 meters. And for measuring smaller length, we use units such as centimeter or millimeter. 1 km is equals to 1000 m, 1 m is equals to 100 cm, 1 cm is equals to 10 mm. Do you know? In some scales, you might have noticed another scale marking. This scale marking is in inches, where 1 inch is equals to 2.54 centimeter. In earlier days, units such as inch or foot were used to measure length. These units are still used by some people. Suppose we all measure the length of the table again, but this time using a meter scale. Will our results still be different? No, but we should first learn the correct way of using a scale to measure length. 5.3 Correct way of measuring length. For measuring any length, we need an appropriate scale. For example, if you want to measure the length of your pencil, you may use a 15 centimeter scale. Similarly, the height of a room is used to be measured. You may need a meter scale or a measuring tape. You cannot directly measure the girth of the tree or the size of your chest using a meter scale. For such measurement, flexible measuring tape such as Taylor's tape is more suitable. While measuring length, we need to take care of some points. What is the correct way to place the scale? Place scale in contact with object using object along its length as shown in figure 5.4. What is the correct position of the eye while reading the scale? For example, if you are trying to measure length of a pencil by aligning it with a scale, the position of your eye should be directly above the tip of the pencil as shown in figure 5.5. How to measure the length if the ends of the scale are broken? If the ends of the scale are broken or zero marking is not clear, it can still be used for measurement. With such a scale, use any other full mark of the scale, say 1.0 centimeter, figure 5.6. Then you must subtract the reading of this mark from the reading at other end. For example, in figure 5.6, the reading at one end is 1 centimeter and at other end is 10.4 centimeter. Therefore, the length of the object is 10.4 centimeter minus 1 centimeter, that is 9.4 centimeter. Do you know how to visually challenge students measure length? They use scales with raised markings that can be felt by touching them. Activity 5.1 Let us measure. Select some objects around you, such as comb, a pen, a pencil, and an eraser, to measure their lengths. Measure their lengths one by one using meter scale. and note down the measurements in table 5.2. Table 5.2, measuring lengths. Why are some length measuring devices made up of flexible materials? While writing the length, do not forget to write the unit also. Thus, your result will consist of two parts. One part is a number, and the other part is the unit of measurement. Some of your friends in the class would have measured the length of the same object. Compare the lengths measured by you with that of your friends. Are the measured length the same or slightly different? If not the same, discuss the possible reason for the differences. Do you know units of length such as kilometer, meter, centimeter, and millimeter begin with lowercase letter except that beginning of a sentence? Their symbols km, m, cm, and mm are also written in lowercase letters and are never followed by s for the plural. Note that a full stop is not written after the symbol except at the end of the sentence. While writing the length, always leave space between number and the unit. 5.4, measuring the length of a curved line. Anish and his parents fixed electric string lights on the arches of veranda of their house. As shown in figure 5.7, for a celebration at home, how would they have measured the required length of the string lights? In case of a curved line, measurements can be made with the help of a flexible measuring tape or by using a thread as shown in figure 5.4. The thread can then be straightened and its length can be measured using a meter scale. 5.5, describing position. One day, the teacher informs her student that she has planned an educational visit to nearby garden. She asks the students to reach there directly in morning. Deepa and her friends start discussing whether the garden would be closer than their school or farther. Tasneem and Padma say that the garden would be closer, while Deepa and Anish feel that the school would be closer. Hardeep thinks that both would be almost at an equal distance. Figure 5.9, location of bus stand, school, garden, and houses of Deepa and her friends. What do you think is correct? All of them are correct. Figure 5.9. Then why are their observations different? They are locating at the distances of the school and garden from their houses. If instead each of them had thought of distances for a same object or point, say bus stand, then their observation would have been the same. When distance is started with respect to a fixed object or point, then this point is called a reference point. A few days later, Hardeep tells his friend excitedly, let us all go to the playground. The sports teacher wants us to help her draw lines with chuna powder, limestone powder for making the kabaddi court for the sports day. Padma, we will need a longer measuring tape. Let us take it from the sports room. Figure 5.10. Deepa, let us first decide point on the ground from which we will measure distance to start drawing the lines. Let us call this our reference point. Figure 5.11. Drawing lines for Kabaddi court. After a few days, Padma was traveling by bus to visit her grandparents in Delhi. She was eager to reach Delhi and was reading kilometer stones on side of the road. On one of the kilometer stones, it was written Delhi 70 km, figure 5.12. Further, on the next kilometer stone, read Delhi 60 km. Each kilometer stone indicated to her that she was getting closer to her grandparents' house. These kilometer stones indicated her distance from Delhi. So Delhi is reference point in this situation. What do such kilometer stones indicate? How could Padma conclude that she was getting closer to her destination. 5.13 Position of kilometer stones with respect to Delhi as a reference point. If kilometer stone reads Delhi 70 km as shown in figure 5.13, we can say that position of Padma is 70 km from Delhi. When kilometer stone reads 60 km, the position of Padma is at 60 km from Delhi. Does this mean that the position of Padma with respect to reference point is changing with time? When does the position of an object change with respect to a reference point? Does it change when an object is moving? 5.6 Moving things. Activity 5.2 Let us explore. Look around and prepare a list of 5 objects that are in motion and 5 objects that are at rest. Record your observations in table 5.3. Think about how you decided whether an object was in motion or at rest. Write your explanation justification in table 5.3. Table 5.3 Observing things around you. Compare and analyze your justifications. How can one decide if an object is in motion or at rest? An object is said to be in motion if its position changes with respect to reference point with time. If an object is not changing its position with respect to the reference point with time, it is said to be at rest. More to know. Deepa looked around her in the bus and noticed that all the passengers were seated. She looked around again after a minute and found them still occupying their seats. She wondered, are they moving? She concluded that position of passengers was not changing with time, therefore they were certainly at rest. However, when she looked outside, she felt they were in motion as their positions were changing with respect to things outside. The reference point is important in deciding whether an object is at rest or in motion. If Deepa considered herself or the bus as the reference point, then passengers were at rest. However, if she considered any object outside bus, say a building, as the reference point, then the passengers and bus were in motion. Think it over. Suppose you are traveling on a ship which is moving at a constant speed along a straight line on a calm sea. Suppose there is no window on the ship. Is there any way that you can determine whether the ship is moving or is stationary? 5.7 Types of motion. Activity 5.3 Let us explore. Take an eraser and drop it from a certain height. Observe its motion. Does it move along a straight line? When an orange drops from tree, does it move in a straight line? Have you seen the Republic Day parade? Recall march past of students during the parade. Do they move on a straight line path? When a heavy box is pushed, it may also move along a straight line. Figure 5.14. When an object moves along a straight line, its motion is called linear motion. Identify such linear motion in your surroundings. Figure 5.14 Linear motion. But do things always move along a straight line? You might have enjoyed playing on swings and merry-go-rounds. Are these types of motion also linear motion? Activity 5.4 Let us investigate. Tie an eraser or potato at one end of a thread. Hold the other end of thread with your hand and whirl it. Figure 5.15 Observe its motion. Is the motion of eraser the same as that of a merry-go-round? When an object moves along circular path, its motion is called circular motion. Figure 5.15 Circular motion. Activity 5.5 Let us investigate. Tie an eraser or potato at one end of a thread. Hang eraser by holding the other end of the thread. Figure 5.16 Keep your hand steady. Using other hand, take the eraser slightly to one side and then release. Figure 5.16. Does it start moving to and fro? Is its motion similar to the motion of a swing? When an object moves to and fro about some fixed point, its motion called oscillatory motion. Figure 5.16 Oscillatory motion. Activity 5.6 Let us investigate. Take thin metal strip of about 50 cm long. Hold its one end pressed to a table. You may use few books or a brick to hold it. Figure 5.17. Press the end of a strip slightly and let it go. Observe motion of this end of the strip. Does it move up and down? This is also an example of oscillatory motion. Figure 5.17 Oscillatory motion of a metal strip. More to know. If an object repeats its path after a fixed interval of time, its motion is said to be periodic. When an object is in circular motion, it moves along circular path again and again. An object in oscillatory motion also repeats its motion while moving to and fro. Both circular and oscillatory motion are periodic in nature. Activity 5.7 Let us identify. Look at the picture of a children's park, figure 5.18, or visit a children's park. Observe different kind of motions, classify them as linear motion, circular motion or oscillatory motion. List them in table 5.4. Give your justification for why you put each in certain category. Figure 5.18 Types of motion observed in a children's park. Table 5.4 Types of motion. Here we end the reading of chapter 5 of class 6th.